for the next talk, we have Charlie on stage with a presentation on time series. Please welcome Charlie.
Hi, I think I have to adjust it because I'm not tall. Hi, can you hear me? Okay? Yeah, good. So yeah, I'm going to talk about time series analysis with seasonal data, which is a project that I did before. So for a couple of things before I dive deep into it, there's the hashtag PyCon UK. Maybe you can't see it very well, but yeah, you know the deal. And or you can follow me on Twitter and find me on GitHub, whatever. So, okay, I haven't used this before. Okay, yeah. Maybe if you have been to the first day, I've given a lightning talk. So I'm a co-organizer of the AI Club for Gender Minority based in London. Also, London Python Sprints. So if you are based in London, you want to be, join our meetups, which is free, then go on meetup.com and find us. Or if your company want to host some free meetups, because we need to find some space, and also maybe sponsor some pizza or drinks, because we organize free meetups. All of the organizers are volunteers, so we need support. And also, yeah, nothing more. Okay, so time series. What is a time series? Just to kind of because this talk is for beginner, I'm trying to cover all the basics. So time series is a certain type of data which is sequential. So the order really matters. So you can't shuffle the data by order. Like for example, the Titanic data set, if you already came across, that's not sequential data because passenger A and passenger B, you can swap them. It doesn't really matter. But for time series, what happened yesterday and what happened today, you can't really swap them because the things happened yesterday is in the past, and there's an order to it, so you can't swap them. And also for time series, a very frequent thing that we would do upsampling and downsampling, because sometimes, for example, if you have some data which is a reading from a meter that it just takes some readings at a certain period of time, there could be some offsets. It's not you want data at maybe every 10 minutes, but the reading is not exactly every 10 minutes. It could be a little bit off. Then you want to maybe I should aggregate them to have maybe the sum of each hour. Then you want to downsample it, or sometimes you want to upsample it because you miss some data at certain reading because it's not very accurate, and you just want to fill in the gap there. So you want to upsample it to divide it to a smaller, and then you can fill in the gaps, like fill in the NA, maybe do some estimate by taking the average or something like that. And also, there's a very good tool all the data scientists love is pandas. In a panda data frame, it's also very handy to deal with all these time series data because you can use daytime index. So all the data will be ordered and labeled with the timestamp that you can you can also use other methods like the time delta methods to find the difference between after two timestamps, how much time have gone through? Is it a day or a week or an hour? So you can find that. Okay, so seasonal data. So you now have a series of time series data that goes on, for example, for a year. And then you have some measurement each day, but you see that there's a pattern. For example, it's a sale in a shop. So maybe people tend to go on shopping more in the weekend, so you get more sales, for example, on Saturday, and it's more or less the same. But if you compare Saturday to maybe let's say Wednesday, then maybe Wednesday people are just in the middle of the week don't get the mood to go shopping, just want to go back home. So that's actually, you will see that there will be a cycle, a pattern that goes on. For example, each week there will be a cycle. But a cycle is not limited to a week. It could be, an hour or even smaller. It could be each minute, because if you, for example, you have some data that measure a fraction of a second, then maybe you can find some cycle which is every minute, something like that. So that marks the seasonal data because there's something repeating. And then it's very common that we want to compare that. At the same point in that cycle, what happened? For example, the shop example, I want to compare if I am doing better in sale. Maybe I want to compare all the weekends together, not comparing weekend and weekdays. So there is, I mentioned Titanic data set before. So the contrast to that is like air passengers, which is also a very typical data set that is 101 for data scientists. Like maybe they want to learn this type of data, they will use this air passenger, but it's not non-sequential. It's sequential. It's the time series data. So for this air passenger data set, then you can see actually there is a trend, there is a cycle. The trend will be, because it's the passenger for each month, the travel. So there you can see that there is actually a cycle. For example, high season and low season for each year. You will see the difference. So it's like here, and then that's the cycle. And then for the trend, it's like each year maybe more and more passengers traveling because the economy is getting better, and more people tends to travel compared to last year. So that would be the trend of going up. But also that's very interesting thing, because in this world nothing is perfect, right? So like other than the trend and the cycle, we also got some noises. It could be slight changes. For example, for a certain month, maybe this winter is suddenly getting really cold and people don't want to travel, and then there will be some noises, which kind of is out of the trend, out of the cycle, is not very easy to predict, because it's basically just noise, just random, and it would happen across time. So basically, we can kind of think about time series data, especially seasonal data, is a combination of the three: trend, seasonality, and noise. So when I was given a set of highly seasonal time series data, what methods shall I use? Of course, there's a well-known method, auto-regression, or even more sophisticated, you can use ARIMA, which stands for auto-regression integrated moving average model, which kind of use the three things. Auto-regression is like linear regression, and then which is done automatically, and integrated, which is using the integration to estimate, and also using a moving average. Basically, these three methods to estimate the next time step using the previous ones. But it doesn't work really well with seasonal data, because all these method is basically doesn't take into account the cycles that I mentioned before. There's a modification of this ARIMA method, which is called seasonal ARIMA. So it kind of adding one correction term, which kind of deal with the seasonality. So it's called that's a typo there. Sorry, it should be S ARIMA. I don't know why I missed the A, or Sarima Max. So that should be an A here. Sorry about that. And then these methods, actually you have to kind of put down what hyperparameters for those to be able to predict it. So usually there's like P, D, and Q, so which is like the terms for auto-regression, integration, or moving average to put in to predict the next point in the time series. But that's not necessarily what I want, because in that project I want to break down a time series into the three things that I mentioned. And I want to analyze on the noise, because I would go into detail about the project, but that's basically not really in line with what I want. So I keep searching, and I will find a more suitable library to use. So I keep scratching my head, like, we have seasonality, like what's the best way to deal with it? So okay, this is about the problem. So the company is a wholesale company in travel. So what happened is, like, they actually B2B company. They have clients, which is worldwide. So some of the clients, they may not open business in public holidays or Sundays. Because Sundays nobody really, like, people just chilling in the house. Nobody go out. So and also that's the weekday differend. But the worldwide nature of this business also means that public holidays got to be different. Even the weekend, weekday definition would be different, in the Middle East and in the rest of the Western world. So all this is kind of interesting, and we have to really be careful about that. So come up with a workflow to deal with this problem. So as I said, is the geographically is global, so every single country have their own tradition, own cycles. So we have to break it down into countries. So don't analyze the whole thing in a chunk. You have to select data by countries. And also, I want to break it down. I want to find the noise that is in the time series. So I want to break down into trend, the seasonal cycle, and also the noise. So that would be something that I need to find to be able to let me do it. And then afterwards I'll show you this LC lower control limit and then upper control limit, like what was it about, like because for the noises you have to set a boundary because normally things are noisy, right? Real world problem. So what's abnormal, what's within the normal range, we have to define that. And also we have to cross check with the fact that we know, because we all know when holidays happening, right? We can plan holidays and we know that when we're gonna, there will be bank holiday, we can, go to maybe Italy for 3 days. So it's known fact. So we can actually cross check our data, our analysis with these holidays that we have. And at the end we will calculate the impact of a holiday. Oh, that's the goal. Sorry, I put it really messy. The goal of the project is to find the impact of public holiday on the business. So so that's why I want to know the noise. I want to know what's beyond the normal range. So I found this library, which is I think it just do the job for me. There is that's the how it works, right? The trend line estimate is basically it's using something to smooth out all these noise and seasonality. So how does it do it? Is to use a median filter. So if you know what a median filter is, it's like for a certain window, it will take the median of that to be the value. So that's the median filter. And also using a low pass smoothing method to do it. And then afterwards, there will be the slope that fit into it, so kind of estimate the next point in the trend. All this is like mathematical details is in the GitHub page. So if you want to dive deep into it, you can click. I will upload the slides to the Slack later, so you can really click onto it and check it. And also there's a seasonal estimate, which it's the special about it is not fixed, because things could change. Like maybe the cycle or the trend, mainly the cycle, it could change for some real life data. It won't always be the same. Not that obvious in my data because it's business. Usually it's like weekday, weekend cycle. But maybe over time, like after a lot of time, maybe shops tends to open on Saturday, only close on Sunday, which before the shops are closed on Saturday and Sunday. So that could change in some kind of seasonal behavior. So having it not fixed and being it estimate automatically over, we have the, calculate the average for each period. So you can see does the period change over time. So that's really good things to have. Not so useful in my case, but it could be useful in certain cases. Also, it tests it will find the period for me automatically. So compared to ARIMA, so which you have to give the seasonal period inside the algorithm. For this one, it will test it automatically for you. So it uses the R square of the leave one out cross validation. So it's like, when you do a grid search, if you're doing machine learning, you do a grid search and then you could do cross validation and then you can find which one is the best one to choose, which parameter, like hyperparameter to use. So basically it's doing all these at the background for you. But the drawback is, because it's doing all these amazing things, it could take quite a long time. So this is the result. As I said, I want to find the impact of a holiday for these travel data. So you can see the data here. I will explain a little bit. For the orange data is the original, is the growth cell of that company. So you can see that it's highly seasonal, and because you see all these up and downs and things like that. And when we break it down, there is a trend, which is the green line there. You can see there's actually some hidden up and downs there, which is not very obvious, but with the program you can find it. And then for the blue one, it's just that it's taken away the cycle. So it kind of, as I said, the filter is applied. So you can see that, the low pass smoothing and all these. So all these, up and downs is more mild. And then afterwards, the purple ones are the ones that's like leaving out. So you can see that all these are actually noises. But I would say that it's still, there's still a little bit of seasonality in it, and that's why kind of we have these two lines there, which is the upper and lower control unit. So you can kind of assume that everything within this range is actually normal trading oscillations, and I think that's outside is the really impacts that's done by the holiday. But we are not sure. Like, this looks like a holiday, but we are not sure. As I said, we know when the holiday happened, so all we need to find is this number, but we can cross-check, does the holiday happen at this time? So we use Google Calendar API to get all the holidays, like what is the holiday this year? Is that, if you compare week to week from last year, is it a holiday last year? So we can kind of see that our impact of the holiday. For example, today is some kind of, let's say today is Easter this year, but Easter doesn't always happen in the same week at the same date, right? It could happen, maybe last year Easter is a month ago, or not that extreme, maybe like three weeks ago, things like that. So we all want to compare it to the same point in last year. So we will have, for example, holiday last year, which means that the same week of the year at the same date there was a holiday, and also it will find what happened this year as well. For example, like for this week, and then Thursday there is a holiday in Spain, so it will tell you where is there a holiday, and then is it a holiday this year or is the holiday last year. So we get all these information which we can compare it with our graph here. So at the end, after cross-checking, of course, if there's not a holiday, we'll just ignore it. If there's a holiday, we will pick it out, find this difference. That would be the impact. I think I've said it somewhere before. If I can scroll it back. Yeah, the impact will be the residual, which is the purple line there in that slide, and then minus the band, the lower limit of the band that consider normal. So that's the amounts that is away from normal that we pick out. And then if I plot it in a kind of a world map, you will see that this is what happened in Christmas. Red means that compared to last year, there is impact. So you can see that this year everybody enjoys Christmas. So nobody's really like doing business or something. They just chill out or meet the families and friends. So you can see that in Australia the business is bad because of that. But it's very interesting. If you look at China, it's not really affected actually, or like shops. Because I come from Hong Kong. Like what happened in Christmas is like all the shops in shopping mall, they open, they do business, they do discounts. They're happy that they're welcoming people to go shopping. So that's the cultural difference you can see there. But for Chinese New Year, it's the opposite, the other way around. It's nothing special in the Western world, but in China, it's all the shops closed for a week. So that's what happened. And yeah, I think that's the end of my presentation. If there's any more questions, then yeah.
Plenty of time for questions. Any questions? Cherry, I have one.
Yesterday we watched an interesting presentation on using Spark, and I wondered if you've actually investigated using Spark. As you say that some of the times the calculations are very slow, but Spark is pretty powerful to farm out the work.
Yeah, for this project we didn't use Spark because I would say that there isn't a necessity to use Spark in this case because there's not enough data and we don't need a lot of computational power to do it. So that's why I haven't used Spark. But that may be a very interesting thing to do if you have a lot of data and you want it to speed up.
Other questions for Cherry? Yeah.
You are looking at a bunch of curves and finding the smaller curves. For me, what a curve, I would see a Fourier transform there. Have you attempted something like that?
You mean finding the period
The periods.
using for transform? I think the special thing about this algorithm is, as I said, they are not fixed. The period is not fixed. So if you take a Fourier transform and then you pick maybe like the frequency that probably there will be a cycle per week or there will be a cycle per month, then it doesn't lose that flexibility of adjusting itself. Because, for example, for this case, maybe that would be a better way, but the advantage of this library is that if you have something like, for example, the traffic of people, so it may not be a fixed period of a week, it could be something else, strangely, then, and also it could maybe it change over time. Maybe in summer the period will be 6 days. In winter the period is 4 days. So if it changes over time, then this library, they use the way to estimate it. It will accustom to this change. If you're interested, you can read in the GitHub. They have the README. They have like the citations at the back, at the end. So if you're really interested to know the method they use, you can look at that. But I don't have time to cover it. So yeah.
Other questions? I have one. You mentioned the air passenger dataset. So for people who are learning about time series analysis, are there other open data sets that are maybe richer or different domains, or what would you suggest?
Now I only know about the air passenger dataset, but I'm sure if you go to there's one, I believe is UCL, they have a library for open data. So they label all these kind of different characteristics of data that you could download and use it open source. I'm sure there's more there, but the most popular one is like, air passengers like Titanic for the classification. So yeah, I only know about that. And also I came across a lot of time series at work. So yeah, if you want to try it yourself, I recommend you go to that open library that you can download data set from. Yeah.
Thank you for the talk. I have a question about the prediction. So using this method compared to the traditional one, like have you tested out the prediction rate and how good it is?
Yeah, it's not a direct comparison because the problem here, I'm doing some analysis which is not a direct prediction of what's happening in time. Of course, you can do some prediction, and then there's another project, there's a newer project that is using autoregression to predict the next point in time, and then you compare that with the actual data so you can find the difference and detect the anomaly. But for this case, because we know that in that time something may happen, because we know that there will be a holiday, right? All we want to know is like how much it differs from what if it's not a holiday. So this method suited well. I think using prediction it will also work as well, but it's just that in this project I choose this approach to use it. I think it's an alternative that maybe for some people this one may work better. Yeah.
Yep. Thank you.
Other questions? Okay, let's thank Cherry one more time.
Yeah. Thank you.